All amounts were off by factors of 10 or 100. The database, API, and frontend all typed currency precision as number, structurally identical, semantically incompatible. Let's break down Full-Stack Type Safety Ultimate Guide, how it works, and the exact mistake behind that failure. Full-Stack Type Safety standardizes the entire data pipeline to one type system. When a specification changes at the database, every downstream layer automatically knows about it and refuses to compile if it cannot handle the change. Full-Stack Type Safety starts at the database. Drizzle ORM infers types directly from the schema definition, no generate command, no sync gap. The moment you update the schema file, the types update. Here's a Drizzle schema for a user's table. Notice we define the schema once and infer the TypeScript type using infer select. Never manually write an interface that mirrors this. That creates a second source of truth that will drift. TypeScript types are erased at compile time. They don't exist at runtime. Zod bridges this gap by providing runtime validation that also produces TypeScript types. Validate at every boundary where untrusted data enters or exits your system. Here's a Zod schema for creating a transaction. Notice the coerce date to ISO string helper. It handles the date serialization gap. Drizzle returns date objects, but JSON serialization converts them to strings. This schema accepts both forms and always outputs an ISO string. tRPC eliminates the most fragile part of the type safety chain, the API contract. It infers types directly from server procedures into client calls, no codegen, no sync gap. Every procedure must define both an input and output Zod schema. Here's a tRPC procedure for creating a transaction. It uses input to validate incoming data and output, to validate the return value before sending. The validate output function catches internal drift that TypeScript inference alone cannot detect. The frontend is the end of the type safety chain. It consumes types, it never defines them. Every type the frontend uses must be inferred from the API layer or imported from the shared package. A front-end developer who writes interface API response has created a second source of truth. Here's a front-end component that consumes types from the API. Notice we import transaction response from the shared API package. We never redefine it. We use pick to derive component props from the canonical type. When the API changes, this component will show a compile error. Shared types are the glue that connects all four layers. In a monorepo, the shared type package is the structural foundation. It must contain only the intersection of cross-layer types, domain types, API contract types, and utility types. It must have zero framework dependencies. Here's a shared type package. It contains branded types like userid, API contract types like paginated response, and utility types like require fields. No framework imports. This package is pure TypeScript. Every layer imports from here, ensuring a single source of truth. This is the same issue we highlighted at the start. Here's exactly why that $2.3 million incident happened. A fintech team shipped a new field account type as int in the Java DTO, but string in the TypeScript client. The frontend rendered 2 instead of checking, causing $1.02 in misrouted ACH transfers. No compile error, no runtime exception, just wrong data for 3 hours. The API returned currency precision as a raw integer without output validation, so the frontend received a number instead of decimal places. Adding output validation in tRPC ensures the return value matches the expected shape. The fix is to always generate client code from the server schema. Use a single source of truth like protobuf or OpenAPI and regenerate on every build. Never handwrite API types. The compiler becomes your cheapest integration test. A front-end team defined their own API response types for 40 endpoints. After a backend refactor changed 8 response shapes, the front-end compiled without errors. The manually defined types matched the old shapes. TypeScript saw no issue. Runtime errors appeared in production because the actual data did not match the manual types. A team manually maintained TypeScript interfaces mirroring their Prisma schema. After 6 months, 23% of interfaces had drifted from the actual database schema. Runtime errors appeared only in production when specific query paths were exercised. A team added ZOD output validation to all tRPC procedures. Every procedure with a created@ field started throwing immediately. The cause: Drizzle returns date objects, but the ZOD output schema used z.string, datetime. tRPC had not serialized the response, yet when the output schema ran, it was validating a date with a string schema. A team used tRPC without output schemas on 30 procedures. After a refactor changed 5 return shapes, the front-end compiled without errors. tRPC had inferred the stale return types. They matched the old function signatures exactly. Runtime crashes appeared because the actual data did not match the inferred types. The article uses drizzlezod 5 with a callback refinement signature schema equals schema. In drizzlezod 6+, the refinement API changed to accept a ZOD schema directly without a callback. If you update refinements from email, schema equals schema email. To email, z.string, email. Check your drizzlezod version before copying code. The article mentions incremental migration but doesn't show code. Here's a concrete pattern. Wrap an existing REST endpoint with a ZOD output schema and a validate output call, then gradually add input validation. This lets you introduce type safety without rewriting the entire API at once. Running validate output on every response adds runtime overhead. In high-throughput endpoints, e.g., listing thousands of transactions, ZOD safe parse can become a bottleneck. Profile your endpoints and consider using zparse with a try-catch and hot paths, or skip output validation on read-only endpoints that are already covered by database constraints. The article's blanket recommendation to validate every output may not suit all production loads. To debug type safety issues, log full ZOD validation errors to your monitoring system. Use validate output on every API response to catch drift early. Check for the date serialization gap. It's the most common silent failure. And verify your shared package has no framework dependencies. Let's run through some common interview questions. What is full-stack type safety? A single type definition flows from DB to UI, enforced by the compiler at every boundary. Why does Drizzle type numeric as string? JavaScript floats cannot represent large decimals precisely. String preserves precision. What is the date serialization gap? Drizzle returns date objects. JSON serialization converts to string. Output schemas must handle both forms. And a few frequently asked questions. Do I need full-stack type safety for a small project? No, it adds overhead. Use it for systems with multiple services or teams. Can I use full-stack type safety with REST APIs? Yes, use TS-REST with the same ZOD schemas. What is the most common failure point? The date serialization gap between Drizzle and JSON output. Let's recap the key takeaways. Database schema is the single source of truth. Validate at all 4 boundaries with ZOD. tRPC infers types without CodeGen. Frontend consumes types, never defines them. Ready to go deeper? Up next, introduction to JavaScript, then variables in JavaScript, then data types in JavaScript, and operators in JavaScript. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.